What we're going to do today is actually we're going to start to connect the Ecell with delta G. And the equation that connecting the two is this one. So your delta G is going to be equals to negative n times a constant f times your Ecell. So this is actually a very important equation that you need to memorize. The n is the number of mole of electron that got transferred in redox reaction. And then the F is so-called the Faraday constant. So the constant is actually 9.6485 times 10 to the 4th coulombs per mole. So the important thing that we should know is that if a reaction is spontaneous, then your delta G is going to be negative. So since your delta G is going to equal to negative n times F times your Ecell. Therefore, we know in order to have a spontaneous reaction, then your Ecell has to be positive. Because only when this thing is positive, this is a constant, right? This is actually number of electrons is always a positive number. Therefore, we know only when your Ecell is positive, you are going to give a negative delta G. Therefore, the reaction will become spontaneous. In other words, if you see a chemical cells where its Ecell is positive, then you know it has to be a spontaneous reaction. Therefore, you know it has to be a galvanic cell. How do you actually calculate delta G of a redox reaction? Previously, we actually learned zinc solid plus copper 2 plus. They form a galvanic cell. It gives you zinc 2 plus copper solid, where we know the Ecell, or the E naught cell in this case, is 1.1 volt. If a question asking you, okay, what is the delta G of this redox reaction? So delta G is equal to negative n times F times your Ecell. Since I know my Ecell is actually 1.1. Faraday is a constant. If I can figure out the number of electrons got transferred in this balanced equation, then I can actually calculate my delta G. So now the question is actually how many electrons are transferred in this equation. So let's look at the things more carefully. Zinc solid plus copper 2 plus. That give you zinc 2 plus copper. So what is the oxidation number of your zinc solid? 0. Copper 2 plus, 2 plus, right? Zinc 2 plus, 2, right? Copper 0. That is actually your LoRa, right? And to lose 2 electrons. Then your G-rock will be this one, right? You go from 2 to 0. That means actually you gain 2 electrons. So in this case, the number of electrons given out is equal to the number of electrons that taken by the copper 2 plus. Therefore, you know the number of electrons that transfers is going to equal to just 2. Once you figure that out, then you can calculate your delta G is going to equal to negative n is 2. Faraday constant is 9.6485 times 10 to the 4th power times Ecell 1.1. The unit of this is coulombs. The unit of your Ecell is volt. If you have 1 coulomb times 1 volt, they give you 1 joule. If you do all this calculation, you got a number of negative 2.10 times 10 to the 5th power. Coulomb times volt, that's going to equal to negative 2.10 times 10 to the 5th power joule. Okay, another thing I want to mention here is that you can see here, I put not just Ecell, right? You see this little circle on the top right corner, right? That means actually the things was measured under the standard condition. So here, since we actually use E naught cell, therefore the delta G here is actually also going to be the delta G naught. So as long as you actually perform the things under standard condition, Then the delta G you calculate now become a delta G at standard condition. Then make it delta G now. Okay, so let's actually the first example we want to go through, which is actually the easy one. The more complicated one is actually this guy. N2 plus 3H2 become 2NH3. It gives you the E naught cell and asks you to calculate your delta G. The most important thing is that you need to figure out the proper number of more electrons that got transferred, right? Again, we start from figuring out the oxidation numbers of the atom first. N2, 0. How about H2? Okay. Now you got a compound. You have 2NH3. What is the oxidation number of your H? +1. How about your N? -3. So this is actually the step that you need to be super quick. Okay, you don't have time to waste on figuring out the oxidation number of every single atom. Second step, you figure out who is actually your low rock, who is actually your G rock, right? Here to here, you actually lost 1 electrons per hydrogen, right? The G rock will be your M, right? So you go from here to here. Therefore, you know you're going to gain 3 electrons per nitrogen. So now you need to actually ask yourself, how many nitrogen I have and how many hydrogen I have? Okay, so how many nitrogen you have? 2, right? Therefore, you know overall for this reaction, okay, since you have 2 nitrogen, therefore for your G rock, you need to gain 6 electrons in total. How many hydrogen you have? Also 6, right? So you know for your hydrogen, okay, since you have 6 hydrogens, therefore you're going to lose 6 electrons. By doing this simple analysis, you know for your low rock, you need to lose 6 electrons. For your G rock, you gain 6 electrons. They must be the same. So once they are the same, then you know the number of electrons that's going to get transferred in this reaction is going to be 6. Getting the correct number of electron transfer is the key. Because I found student doesn't have any problem to connect your delta G with your Ecell. But students always make mistake when they actually counting the number of electrons that got transferred. Therefore, it's very important first you need to identify the oxidation number of every single atom quickly. Second is like you want to know who is your low rock, who is actual G rock. Do you know how many electrons per atom was transferred? Then eventually you multiply the total number of atoms you have, so you will know what is the overall electrons got transferred. So this is a key step to solve this type of questions properly. So once you get that, you actually get your E naught cell here, right? Therefore, you know your delta G naught was simply equal to -6 times your Faraday constant, 9.6485 times 10 to the 4th power times your E naught cell, 0.057 volt. So by doing this simple calculation, you're going to get a number of -3.30 times 10 to the 4th power joule.